Hello everyone, this is Usha and I am your final year BTech student of Sasi in Welfare Institute of Science, Technology and Management. In this video, I am going to explain about my final year project and my team members are L. Vardhan, B. Sushmitha and V. Snehalatha and my project guide is K.Himanth Rao, Associate Professor in Welfare Institute of Science, Technology and Management and my project title is Analysis on Hyperparameter Tuning in dcgans. dcgans means Deep Convolutional Generative Adversarial Networks. These are widely used for generating the new images. In earlier days, if the cartoon companies were wanted to create the new cartoon models, first they had to pay money to the designer to start their work. After the completion of design, it will be inspected by the director for approval. If the design gets rejected, it should be redesigned from starting. So this is a time taken process and money will also be wasted. To overcome this problem, dcgans were used to design the new images without any human intervention. It has been growing very fastly and it is especially used for a lot of companies because they are looking for the ways that they can generate the new data based on the predetermined data. By this model, they can also create new cartoon images or interior designs or audio clips also. Now let's see the existing system. The output of the dcgan are mainly depends upon the hyperparameter which are used in these models. For the beginners who are wanted to build this model, they don't have any idea about what values or what range should be taken to get the desired output. By this project, we are provided the limitations, that is, what range should be taken to get the desired output or better result. In this project, we are training this model on two data sets. There are enemy data set and human face data set. And the remaining part will be continued by the Sushmitha.
Myself, I am Sushmitha. Now I would like to explain about hardware requirements, software requirement, dcgan and generator. Coming to the hardware part, the processor which we are used in this project are i3 and i5, RAM 4 and 8 GB, hard disk 500 GB, graphic card 2 GB. Software requirements, operating system Windows 10, coding language Python. Coming to the dcgan part, dcgan means Deep Convolutional Generative Adversarial Network. They are made up of two distinguished models. One is generator, another one is discriminator. The generator part of GAN learns to create fake data by incorporating feedback from the discriminator. It learns to make the discriminator to classify its output as real. The discriminator in a GAN is simply a classifier. It tries to distinguish between real data from the data created by the generator. Coming to the generator part, the job of the generator is to produce fake images that look like the training images. The generator is designed to map the Latin space vector to data space, where the Latin space is a 100-dimensional hypersphere with each variable drawn from Gaussian distribution with a mean of 0 and standard deviation of 1. In practice, the conversion Latin space vector to data space is accomplished through a series of two-dimensional convolutional transpose layer, each paired with a 2D batch non-layer and a ReLU activation. The input for the generator are NZ, NGF and NC, where NZ is the length of the Latin space vector, NGF is the space of the features maps that are propagated through the generator. NC is the number of the channels in the output images. The remaining part will explained by one of my team member Sneha.
Myself, V. Snehalatha. I am going to explain about discriminator, hyperparameter tuning and dcgan training. Coming to the discriminator, the purpose of the discriminator is to look at an image and output whether or not it is a real training image or a fake image from the generator. This discriminator is a binary classification network that takes an image as input and output is a scalar probability that the input image is real or fake. The discriminator network takes an image as input, process it through a series of two-dimensional convolutional layer, two-dimensional batch norm layer, and finally leaky ReLU activation layer, and outputs the final probability. And next, coming to the hyperparameter tuning. These are the hyperparameter which are used in the dcgan data root. These defines or used to set the path to the root of the dataset folder. Workers. It defines the number of working threads were required for loading the data with the data loader. Batch size. It defines that how many images should be taken at a time. Image size. It is the size of the image. NC. It means number of channels in the input images. For the color images, it is 3, that is red, green and blue. NZ. It is the length of latent space input vector. The generator model takes a point from the latent space vector and generate a new image. NDF. This sets the depth future maps propagated through the discriminator. NGF. This sets the depth future maps caused through the generator. Number of epochs. It defines the number of training epochs to run. Training for longer will lead to better results. LR. It means learning rate. Beta 1. It is the hyperparameter for Adam optimizer. And GPU, number of GPUs available. If this is 0, code will run on CPU mode, or if this number is greater than 0, it will run on that number of GPUs, where GPU means graphics processing unit. In this project, we are using the Celeba Faces dataset and Anime dataset, which can be downloaded from internet. We trained the dcgan model by using these datasets and generated the new images. And next, coming to the dcgan training. A batch of images of the original dataset is given to the dcgan model. A number of noise vectors are equal to the batch size were generated. These noise vectors were used by the generator to create the batch of new images. Now train the discriminator with real and fake images separately. Now generate the number of batches with 2 times multiple of noise vector, and these will be used to train the generator. Now train the discriminator with the generator images. The next part will be explained by the team member of Vardhan.
While coming to my project code, this is my project code which to explore my project. By this line we can download the dataset directly, and these are the libraries which can are used in this project. In this project we will find and train a dcgan on a dataset of faces or anime or cartoons. The goal is to get a generator network to generate new images of faces that look like as realistic as possible. From these tasks, from loading in data to defining and training adversarial networks. At the end of the notebook, we will find able to visualize the results of our trained generator to see how it performs. Getting the data. We will using the self-face attribute dataset to train our adversarial networks. This dataset is more complex than the number datasets we have been working with, and so you should prepare to find the deeper networks and train them for a long time to get good results. It is suggested that you utilize a GPU for training. Since the project's main focus is on building the GANs, we done some of the pre-processing for us. Each of the syllable images has been cropped to remove parts of the images that don't include a face. Then resize it down to 64 into 64 into 3 numpy images. Some sample data is shown below. Create a data loader with appropriate hyperparameters. We can decide on any reasonable batch size parameter, and image size must be 32, and resize the data to smaller size will make for faster training, which still creating convincing images of faces. Here we can view some images. You should see square images of somewhat centered faces, and we will need to convert the tensor images into a numpy type and transpose the dimensions to correctly display an image, and suggested code is below to not be perfect. Pre-process our image data and scale it to a pixel range of -1 to 1. Define the model. A GAN is a comprised of two adversarial networks, a discriminator and a generator. While in discriminator, the task will define the discriminator and convolutional classifier like you built before, only without any max pooling layers to deal with this complex data. It suggested you use a deep network with normalization. You should allow to create any helper functions that may be useful. And the input to the discriminator are 32 into 32 into 3 tensor images. The output should be a single value that will be indicate whether a given image is real or fake. Generator. Generator should unsample an input and generate a new images of same image size as the training data. This should be mostly transpose convolution layer with normalization applied to the outputs. Now we need to calculate the losses for both types of adversarial networks, discriminator losses and generator loss. For discriminator, the total loss is sum of the loss for real and fake images. That we want to discriminate to output 1 for real image and 0 for fake image. So we need to set up the loss to reflect that. In generator loss, we will look for similar only with flipped labels. The generator goal is to get the discriminator to think its generated images are real. In training period, will involve alternating between training the discriminator and the generator. You will use your functions, real loss or fake loss to help you calculate the discriminator losses. We should train the discriminator by alternating on real and fake images. The generator tries to trick the discriminator and should have an opposing loss function. In some code, print out some loss statistics and save some generated fake samples. Training loss for generator and discriminator recorded after each approach. Now training this code, it determines number of training approaches to run. The training for longer will probably leads to better results, but it will also take much longer. After every approach, the completion of every approach, after the first approach, the image is generated. The completing the 30 approaches, the newly generated images for enemy database. And these are the newly generated images from human face dataset and anime dataset and cartoon dataset. While coming to the conclusion, in this project we are taking learning rate as 0.002 and 0.005. It produces new images with good quality, but when take learning rate values as 0.1, it produces noise images. Number of approaches value should be taken in higher value to produce the images with good quality. It better to take minimum 50 images to model to get the better result. Number of channels NC should be taken 3 for color images and 2 for black and white images. Better one hyperparameter for Adam optimizer should be 0.5 to get the better output. Training for longer will probably lead to better results but will also take much longer. Finally, the generator loss and discriminator should be approximately equal to each other and it should not be more than 10. Then only we get better results. Thanking you for giving this golden opportunity to HOD ma'am and principal sir and my guide K.Himanth Rao sir. Thanking you.